Look at this photograph, a column of black oil roaring out of a wooden derrick into the sky. Popular culture has trained us to view this moment as the ultimate victory. The idea is that once you strike oil, the hard work is over, and the wealth simply flows out of the ground. But the initial strike is actually day one of a grueling, decades-long battle. Extracting energy is a continuous war of attrition against subterranean physics, requiring sprawling infrastructure and relentless mechanical endurance. The moment extraction begins, the subterranean architecture starts to compress. The natural pressure that initially forces the crude up to the surface steadily plummets, causing the flow to choke. For decades, operators fought this decline using isolated, manual control panels to monitor individual wells. But reacting to pressure groups with outdated, disconnected gauges means you miss the complex fluid shifts happening deep underground, inevitably leaving millions of barrels of oil stranded in a rock. To extract the absolute final drops from an aging field, mechanical brute force is insufficient. You need a digital mind that monitors the entire reservoir in real time. This is the logic behind OmniPetro's smart production. This animated map illustrates smart production. Isolated wells light up and link together, mapping the field as a single living ecosystem, pulling live telemetry. The AI instantly understands how slight pressure changes in one well alter fluid dynamics across the interconnected grid. This network becomes critical when the field hits its midlife crisis. Eventually, the reservoir's natural outward push dies completely, making artificial lift the absolute lifeblood of the entire operation. To force the oil up, operators deploy Electrical Submersible Pumps, or ESPs, deep underground. OmniPetro monitors the real-time mechanical health of these components while they operate under immense fluid pressure. The AI analyzes continuous telemetry from the pump, reading thermal heat maps and detecting micro-vibrations in the shaft to spot the earliest microscopic signs of mechanical wear. Catching that vibration early allows engineers to adjust the pump's speed before the hardware physically seizes. Keeping the pump running prevents catastrophic well failure and saves millions of dollars in downtime. But lifting the fluid to the surface is only half the battle. As the field ages, surface pipelines often choke on turbulent, mixed fluids, creating severe internal congestion. This schematic demonstrates flow optimization. When the system detects a surface bottleneck, it generates actionable intelligence in fractions of a second, suggesting exactly how to reroute turbulent flow through parallel lines to maximize output efficiency. While the surface flow is optimized, a much larger threat is growing miles below. Over years of extraction, deep subterranean water begins to rise, mixing directly into remaining oil reserves. OmniPetro counters this with water cut monitoring. The system tracks this rising tide of water through the porous rack, calculating the immense energy cost of lifting heavy, non-combustible water to the surface instead of oil. This early foresight allows operators to seal off high water zones or adjust extraction rates before the electrical cost of pumping water exceeds the value of the oil, preventing massive amounts of wasted energy. Actively resolving surface bottlenecks while managing deep water intrusion is the strict operational difference between a rapidly dying field and a highly profitable, optimized asset. Managing the present flow is vital, but maximizing the lifespan of a reservoir requires looking directly into the future through production forecasting. Fusing live telemetry with historical well data, OmniPetro projects exact production declines and identifies necessary future interventions. These forecasts are interactive. If an engineer adjusts a single valve setting today, the AI calculates exactly how that tweak impacts the total yield years down the line. This massive data architecture acts as a force multiplier for the human workforce. It translates billions of data points into the real-time vision and predictive foresight required for high-level decision-making. The human engineers evaluate the AI's predictive models to make high-level strategic decisions, ensuring the operation runs sustainably by actively lowering power consumption and emissions. Extracting the final drop of oil requires this exact balance, the continuous processing power of predictive machine intelligence guided by seasoned human strategy. But maintaining this relentless, optimized flow puts immense physical strain on the hardware itself. Metal and steel must endure constant friction and high pressures. Next time, we will explore predictive maintenance and how the system prevents catastrophic structural failures before they even happen.